Alright, graphing linear inequalities and system of linear inequalities. So we graph linear inequalities the same way we graph a linear equation, but with one extra step. We shade, and there's one difference. Either we have a solid line or a dotted line. So if we have the inequality of less than or greater than, that's a dotted line. The solutions contain only points in the shaded region. And if you have the less than or equal to or greater than or equal to, that's going to be a solid line, and that means the solutions is in the shaded region and on the line. So the difference between the dotted line and the solid line, the dotted line you can only have solutions within the shaded region, but with the solid line you can have solutions in the shaded region and on the line. So let's move to example 1. We want to graph the inequality y is greater than 4x plus 4. So there's three steps to do this. We want to graph it as if it was y equals mx plus b. Then we want to determine if it's solid or dotted line. And then we're going to shade by reading y, the inequality sign, is then x. So I know you might have learned that you have to pick a point and work with that, but I'm going to teach you, you no longer have to pick a point. We're just going to read the function and go from there. So for the first thing we need to do is graph it as if it was y equals mx plus b. So the first thing we need to do is to graph it as y equals mx plus b is the first thing we need to find the start. And remember, the start is the y-intercept, which is the number without the x. So the number without the x, which is going to be 0, 4. So it's that one right there. And next, we want to figure out the slope. The slope is the number with the x. So it's going to be 4 over 1. We can go up and right or down and left. And next, we want to determine if it's going to be solid or dotted. Well, since there's no line underneath, it's going to be dotted. And then we're going to read the inequality. So y is greater than x. After we graph, I'll show you the significance of reading the inequality and how we shade it in. So first, we need to start at our start, which is 0, positive 4. From there, we're going to use our slope and go up 4, right 1. And then I want to go down 4, left 1. Down 4, left 1. I like making a bunch of dots. And then we know we're going to connect the dots using a dotted line. And then we're going to shade. So it says y is greater than x. We don't shade down, because if we shade down this way, and you notice right here, we get into negative numbers and smaller numbers. We don't want that. So what we're going to do is we're going to shade up. The reason why we shade up, because if you notice, the line goes on forever, and we'll get into our higher numbers, our greater numbers. So it's good to know that if it's greater than, you're going to shade above the line. You want to go up. If it's less than, you want to go down, below. Alright, example 2. So we want to graph x minus 3y is less than 6. So in order to graph anything linear, it needs to be in slope-intercept form, which is y equals mx plus b. So let's do that. Let's put it in to y equals mx plus b. So we have x minus 3y is less than 6. So we need to solve for y by subtracting by x. So we have negative 3y is less than negative x plus 6. And now we need to divide by negative 3. And that's where this little stipulation comes in. When dividing or multiplying by a negative over an inequality sign, you must flip the sign. So you see how right here we divided by a negative 3 and it went over the inequality sign. We need to flip the sign. So we'll have y is now greater than 1/3 x minus 2. So just flip the sign if you divide by a negative. Okay, so from there, we're going to do the same exact thing we did for the other example. So we want to identify our start, which is going to be our y-intercept. That's going to be 0, -2. Now we want to determine our slope, which is 1/3. So we can go up and right or down and left. Alright, so from here, we want to determine is it going to be solid or dotted, and it's going to be dotted. And then we want to read the inequality. Y is greater than x. Alright, so let's graph this. We're going to start at 0, -2. So 0, -2. And then we're going to go up 1, right 3. Up 1, right 3. Up 1, right 3. Let's go the other way. Down 1, left 3. Down 1, left 3. And connect the dots with a dotted line. And it says y is greater than x. So since y is greater than x, we want to graph up above the graph, right in this region. Alright, so that's just graphing an inequality. Now let's graph a system of linear inequalities. So to graph systems of linear inequalities, we graph each system on the same plane where the two shaded regions are the solutions. So just like a system of linear equations, we graph both of them on one single plane. And then where the two shaded regions meet are the solutions. So you can pick something from, you can pick a point from the shaded regions and it'll work for both inequalities. Alright, so just like before, we need to figure out the slope, the y-intercept, which is the start, if it's dotted or solid, and then we want to read the inequality to determine where we're going to shape. So for our first one, of y is less than or equal to x plus 3, so our start, which is our y-intercept, is 0, 3. Our slope is 1/1, so I can go up and right or down and left, and it's going to be a solid line because it has the line underneath. That's a really easy way to remember, is it solid or is it dotted? If it has a solid line underneath, it's going to be solid. And then y is less than x. Alright, so let's graph the first one in green. We'll worry about the second one, the purple one, afterwards. So we want to use our start at 0, +3. And I want to go up 1, right 1, up 1, right 1, up 1, right 1, continue on, go the other way, make a big line, and it's going to be a solid line. So we're going to connect the dots with a solid line. And then we're going to shade it. Y is less than x. So when we think of less than, we think of something that's below. We go down. So we're going to shade this region right here. Alright, we're going to do the same exact thing to the purple one and put it on the same graph. So for our next one, we have our start, which is our y-intercept, of 0, +5. We have a slope of -1/1, so I go down and right or up and left. And then it's going to be a dotted line, and it's y is greater than x. So let's go to our start of 0, 5. And we're going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. You know, you don't have to put this many dots. I just like to put a lot of dots. And we're going to connect the dots using a dotted line. And then it says y is greater than x. So when we think of greater, we're going to think above the line. So we want to go up. Alright, so now, this shaded region that I'm going to circle in red, where the purple meets the green, you can pick any point in there. So you can pick 8, 3, and you can plug it into both inequalities, and both inequalities will be true. So you can pick any point within this shaded region, and it'll be true to both of these inequalities. Alright, example 4. So we have 2x plus y is greater than 7, and 3x minus 3y is less than or equal to 12. But remember, when we're trying to graph, it needs to be in slope-intercept form. So we have to put them in slope-intercept form. That means y by itself. So from here, we need to solve for y. So to solve for y for the green one, we're going to subtract 2x to both sides. So we get y is greater than negative 2x plus 7. Alright, we'll worry about the next one afterwards. Let's just continue with this one. So just like before, we need to figure out our start, which is our y-intercept, which is going to be 0. Our start, which is our y-intercept, is going to be 0, positive 7. Our slope is negative 2 over 1, so I can go down and right or up and left. And then our, is it going to be solid? Is it going to be dotted? Well, it's going to be dotted. And if we read the inequality, y is greater than x. Alright, so let's graph this green line. So we're going to start at 0, 7. Use our slope, we're going to go down 2, right 1. And we're going to connect the dots with a dotted line. And we're going to shade it y is greater than x. When we think of greater, we go up. Alright, let's do the same thing to our next inequality. So we need to solve for y by subtracting 3x. So we get negative 3y is less than or equal to negative 3x plus 12. And we need to divide by a negative 3. Remember, when we divide by a negative, you better flip that sign. So we have y is now greater than or equal to x minus 4. So same thing, we're going to label our start, which is our y-intercept, our slope, determine if it's dotted or solid, and then read the inequality. So our start, or our y-intercept, is going to be 0, negative 4. And then our slope is 1 over 1. So our slope is 1 over 1, so I can go up and right or down and left. And then our line is going to be solid. And y is greater than x. So let's graph this. So we're going to start at 0, negative 4. And we're going to go up 1, right 1, up 1, right 1, keep going. We're going to connect the dots with a solid line. And it says y is greater than x, so we're going to shade above. So this region, right here, where the green meets the purple, are the solutions. Alright, so example 5, we want to graph the system y is less than or equal to 7x minus 5, and y is greater than or equal to 7x plus 9. So we separate them. It's great to stay organized, so make sure you separate your problems so you know which one you're working with. You can never be too organized in math. So for our green one, our first one of y is less than or equal to 7x minus 5, same thing, we want to figure out our start, which is our y-intercept. It's going to be 0, negative 5. Our slope is 7, so we can go down and left or up and right. We have a solid line, and y is less than x. Alright, so let's graph this. We're going to start at 0, negative 5, and we're going to go up 7, right 1. We're going to connect the dots with the solid line. And it says y is less than x. So this might be a little harder to determine which way is less than. So if we go this way, if we go to the left, you notice that the numbers will keep getting bigger. So we can have like, negative 6, 100. So that's getting greater than. But if we go down, if we go to the right, which is down, we'll get into the lower numbers. So next we want to graph our 7x is, y is greater than 7x plus 9. So same thing, we want to figure out our start, which is our y-intercept. It's going to be 0, 9, and then our slope is 7 over 1, so we can go up and right or down and left. It's going to be a solid line, and it says y is greater than x. Alright, so let's graph our line. We're going to set it 0, 9. And I'm going to go down 7, left 1, down 7, left 1. And I'm going to connect the dots with a solid line. And it says y is greater than x. So we know from the previous line that right is less than, so we're going to go left. In this case, we don't have any shaded regions. Nothing crosses over, and nothing will cross over. How do we know nothing will ever cross over? Well, if we notice something, they're parallel lines. They have the same slope. Not all parallel lines are no solution. Only if the inequalities are opposites of each other, you will have no solution. So it's just safe to say, graph both. Alright, at the bottom I have extra practice, and on the PDF that I attached to this video, you will get the answers. They're actually at the bottom. I worked them out for you. So I highly suggest you do these 4 problems. They're very similar to what we just went over. And if you have any questions, leave them in the comments.